Any question from last time?
No.
Okay, so last time I stopped at the inverse of the function. So I defined the inverse of the function as the following. The inverse of the function is, let f be one-to-one function. So the inverse of the function defined as y equal f of x. Y equal f of x. Then if I take the inverse for both sides, this is mean f inverse of y equal x.
Excuse me?
Yes.
Is this going to be on the test tomorrow?
This is now, no, the test from 1.4 up to 2.677. This is 2.8. This will not be in the test tomorrow.
You guys don't like have any sort of review or anything for tests or anything, right?
If you have any question, you can email me or you can ask me in the end of this class. Okay.
All right. Thanks.
No problem.
Are you able to do some review like towards the end of the class, like on some few topics?
What do you mean, like?
Or finding the domain for. Let me see.
Yeah, I'm going to go over the domain in the 10 minutes in the end of the class.
Yeah, for the composition functions.
Yes, I'm going over these things.
Okay.
The last minute. Okay.
Thank you.
Let me speak about the test. So the inverse function, so the inverse function is the function as this form. The domain of the function f is the same as the range of f inverse. The domain of f is the same as the range of f is the same as the domain of f inverse. And the cancellation properties, let f is one-to-one function, and I have another function. This function is the inverse function of the f function. So it's supposed to achieve this property. First one, f circle g is the same as is x, and g circle f must be x. This means the function f and g are inverse to each other. I'm going to give you example for the cancellation property. So example, show that f of x equal x cubed and g of x equal x to the 1/3 are inverse of each other. Okay, so to show this function f of x equal x cubed and the other function g of x is x to the 3rd are inverse to each other, I have to use the properties. I have to use the property, the cancellation property. The cancellation property says f circle g of x equal x and g circle f of x must be x. If f circle g equal x and g circle f is x, this means the function f of x and the other function g of x are inverse to each other. Okay, let's do it. So f circle g of x, what is that equal? What is f circle g of x? Is f of g of x. Now you plug the function g of x inside this parentheses. So I get f of g of x from here is x to the 3rd. You plug it inside the function f of x now. Everything inside this function f here. So x to the 3rd, everything to the 3 is equal Here we have x to the third, everything to 3 to the power 3. This is mean we have to multiply the exponent. So 1 over 3 times 3 is 1. And x to the 1 is equal x. So the first one are achieved. Second one, g circle f of x equal g of f of x. Now you plug inside the function g f of x. So g of, here is f of x, x to the 3. Now you plug x to the 3 inside the function g, here. Get x to the 3, everything to the 1/3. Now by using the properties in the first chapter, this is equal x to the 3 times 1 over 3. So this is equal x to the 3 over 3, 1 over 3 is equal 1, and again equal x. So look, f circle g equal x, and g circle f is equal x. This is the mean. This mean the function f and g are inverse to each other. So g and f are inverse to each other. Any question for this? Anyone has a question? Okay, so no questions. So you have to know now here.
Can you go back, please, Professor?
Yeah, sure. Let me write here. You have to know something else. F inverse of x is not equal 1 over f of x. This is not true. F inverse of x is not the same 1 over f of x. But f of x, everything here inverse, this is equal 1 over f of x. This is equal here, not equal. This is how we will assign a question. Okay? Can you move to next slide?
Yes, you can.
Okay. So now we're going to find the inverse function. The question now, how to find the inverse function. So there is here find the inverse of a function. So there are some steps to find the inverse as follow. So how to find the inverse function? First of all, you have to write y equal f of x. I'm going to explain these steps by the example. Then you solve this equation for x in terms of y, if it's possible. Then we have to interchange x and y, and the result of the equation is y equal f inverse of x here. Here f inverse. So here f inverse of x. Okay, example for these things. Find the inverse for f of x equal 3x minus 2. So I'm going to do this one step by step. First of all, write y equal f of x. So I have to write instead of f of x, y equal 3x minus 2. This is the first step. Then solve this equation for x in terms of y. This is mean I have to solve it as x equal something. This is my second step. I have to change everything to make x equal the equation. So next step 2, I have to make x equal something like this. So what I have to do here, how can I solve the equation such that x equal? So this is linear equation here. First of all, I have to move this 2 to this side. How can I shift this 2 to the minus 2 to this side?
Add 2.
Add 2 for both sides. So when I add 2 for both sides, this will be cancelled here. Now I get y plus 2 equal 3x. Now I have to remove this 3. What I have to do?
Wouldn't you divide?
Yes, so I can divide by 3 for both sides, or I can multiply by the reciprocal, 1 over 3. Both of them are right. Divide by 3 or multiply by the reciprocal. So now the 3 with the 3, they are cancelled again here. This with this. Now I get x equal 1 over 3 y plus 2 over 3. So let me do it here. So here I get y over 3 plus 2 over 3 equal x. So I want to make x equal the equation as x equal, I flip x in here in this side and this everything in this side. So x equal y over 3 plus 2 over 3. This is my second step. Third step, interchange x and y. So here I have to change x by y and y by x. Can I move to the next slide?
Yes.
Okay. So now x equal y over 3 plus 2 over 3. Now the third step, number 3, interchange x by y and y by x. So now x become y equal and y become x over 3 plus 2 over 3. Now you can, in the end, you have to write it as f inverse instead of y, and inverse of x equal x over 3 plus 2 over 3. And this is my inverse function. And this is my answer. Okay. Any questions so far for the inverse here? Is it
A
clear?
question.
Yes. What's your question?
Okay. So for this, right, for the inverse, do we only switch to ones that have variables, or we can switch, or we can flip every single thing?
Where?
Okay.
Can,
Say for
yeah.
example, right, in like in
Okay.
this.
In this one. What's your
Yeah.
question? Yeah.
Okay. Say for example, right, in like this situation. So say that it was like 3x squared minus 2x plus,
Okay. Nice question.
like how will we do like a problem like that if they give it to
Okay. The function must be one-to-one. So this function here is one-to-one. But if y equal 3x squared is not one-to-one function.
Oh, okay, thank
And
you.
there's like here, I can plug any element. I can plug any number. When I found the inverse also, I mean like when I plug any element, but they give me one element different. But for x squared is not, I cannot find the inverse. Not all the function I can find the inverse. To find the inverse for the function must be one-to-one. What does that mean one-to-one? Like I explained last time, every element has different domain. So the function here, it's one-to-one function. Every input has different output. But for the function x squared, for example, y equal x squared, y equal x squared, this is not one-to-one function. So I can't find the inverse for this function. No inverse. I hope I answered your question. This is your question? This was your question, Amanda?
Yes, Professor.
Chris? Okay. So not every function has inverse. I mean, like this function is what linear function, so I can't find the inverse. But this function is not one-to-one function, so it's not does not have inverse too. I can't find the inverse for this one. I give you another function, or hold on. Let me give you another function R one-to-one, and I can find the inverse. Let me give you another example. Oh, sorry. Oh, bad. So I don't need it. So example number 2. The example, find the inverse for here. Find the inverse. Find the inverse for f of x equal x to the 5 minus 3 over 2. In the beginning, I will give you hints. This function is one-to-one, so I can't find the inverse. Okay, how I know this is one-to-one? By graphing this function. We don't have to graph this function yet. We don't have to know how to graph it. It's not, but if I want to graph this function, it will be like something like this, like that maybe. And when I test the horizontal line test, it's passing in the horizontal line test from last time. So this function here is 1-to-1. We don't have to know how to graph it, but I give you hints. This function is 1-to-1, find the inverse. So my goal right now to find the inverse. So again, by doing it step by step. First step, going back to the steps, write y equal f of x. So instead of x, I write it y equal x to the 5, x to the 5 minus 3 over 2. Second step, solve this equation for x in terms of y. This is mean I have to write it as x equal, then I have to solve it. So I need to find x equal here. So what I have to do first step, any hint? Any idea what's the first step? I have to remove this. Yes, exactly. Multiply everything by 2. So multiply this side by 2 and this side by 2. So when I multiply by 2, I cancel this by this and I keep this one. So now I get 2y equal x to the 5 plus 3. What is next step? How can I cancel the 3?
So we can subtract 3 on both sides.
Yes, exactly. So I subtract 3 from both sides. Now the 3 with the 3, they are cancelled each other. So I get now x to the 5, x to the 5 equal 2y minus 3. What is
I have a
first
question.
step? Yes, what's your question?
Why is it x to the fifth plus 3, not minus 3?
Here,
Yeah, the red one on top.
the red one in the top. This one?
Right, that one says minus 3, and then you put x plus 3.
Oh, okay. Thank you. Thanks. So this is the question is here minus. The question is x to the 5 minus 3. So we have to add. Thank you, Mobile. So here we have to add 3 for both sides. Because the question is x to the 5 minus 3. So we have to add to cancel the 3. Thank you. So here 2y plus. Now, what's the last step?
So we can do the square root, no, the
This is
right
fifth.
root, the
This
fifth
side.
root. Can we raise everything to the fifth root so we can cancel it out?
Yes. So everything raised to the fifth root. 1 over 5. 1 over 5. So the 5 here with the 1 over 5, they cancel each other. So I get x equal. Here I get 2y plus 3 and everything to the 1 over 5. Now the last step, interchange x and y, then the result equation is y equal f inverse of x. So I'm going to do it this right away. So f inverse of x equal, now I change y instead of x, I get 2x plus 3, everything to the 1 over 5. This is my answer. Any question? Okay, another example. Can I move to next slide or? Can I move to next slide?
Yes, Professor.
Okay. What about the others? Yes. So here the example is let f of x equal 2 minus 3x. The question is find now f inverse for number 10. What is f inverse of 10? So first of all, we have to solve this one to find the f inverse. Then we have to plug the 10. So this is linear, easy to find the inverse. So again, I have to subtract 2 from both sides. No, first of all, I have to write f of x as y equal 2 minus 3x. Now I have to solve, this is the first one. Second step, I have to solve it in terms of x equals something like this. So I have to remove this one or move this one to this side, the 2. To move this one to this side, I have what? To subtract 2 from both sides. Get y minus 2 equal minus 3x. Now I have to cancel the minus 3 from in front of the coefficient of x. I do that, like I said before, by multiplying by the reciprocal 1 over minus 3. Multiplying by 1 over minus 3. For everything here, for everything here. So the minus 3 with this one, they cancel each other. Now I get x equal minus 1 over 3 y, and here minus times minus is positive. 3 times, they get 2 over 3. So now I change instead of x as f inverse of x equal minus 1 over 3. Here instead of y, this is the third step, instead of y, make it x plus 2 over 3. So this is my inverse function. Now the question is find f inverse of 10. I have to plug the 10 inside this function. Who will help me for this one? What is f inverse of 10?
Wait, I have a question.
Yes.
Are we substituting 10 in for x to solve the equation?
We're here. Which step?
Go again?
Which step?
The last step where you said,
This one. So for the last step, instead of x, you write it f inverse of x. Instead of y, you write it x. But I flip it.
okay, so where we have like f inverse 10 equals, are we gonna put,
You plug the 10. Yes.
you plug the 10 in wherever we see the x?
Yes, exactly. This is what I'm going to do. So here, let me write it again. Here, I'm moving this x for student who will not make sure. this x, I move it to this side, and everything to this side. So I get x equal -1/3 y plus 2/3. Now plug the 10 inside the inverse. Plug the 10 inside this function. So what I get? -1/3 inside this x, 10 plus 2/3. Simplifying these things, I get -10/3 plus 2/3. The denominator are equal, so we just do subtracting for the numerator. So -10 plus 2 is -8/3. This is the answer. This is the answer for this thing. Find f inverse of 10 is -8/3. Any question? Okay. So now the graphing of the inverse function. Graphing of the inverse function. So we have to know the graph of the inverse function, f inverse, is coming from by reflecting the graph, the original graph f, by the line y equal x. I'll show you that. So to graph the inverse by reflecting to graph the inverse function f inverse here by reflecting the function f in the line y equal x. Show you, explain that. So suppose my graph like this. This is my graph, my function of x, something like that. This is not one-to-one. It must be one-to-one. This is not a good graph. It's a graph like this. This is one-to-one function. This is the function f of x. So to graph the inverse for the function, I had to reflect everything around the y, the line y equal x. So this is the line y equal x. This is my mirror, y equal x. It's y equal x. I have to reflect all the point around this line. So this point, when I reflect it, for example, gonna be like something like this here. This point will be like around here. This point will be like around something like this here. So the graph will be something like this. This is the reflecting for the function. This is the f inverse. So here is f inverse of x. Let me change the color for this one by using dark color. So this is the line y equal x. So reflecting all the point from the original curve around this line. So this point again here, this point like around here, this point here, this point here. So now we know how to graph the f inverse. Any question for the graphing? Okay, let me give you example. The question is, graph the function f of x equal square root of x minus 2. Then after you graph the function, first step, find the equation of f inverse of x. Number 2, sketch the graph of f inverse. So first of all, graphing the function f of x equals square root of x minus 2. So we know how to graph this one. This is like review from previous section. The original graph here is the square root. Okay? Again, what is the original function? Is the square root. So the original function here is the square root of x. And the graph for this one is something like this. This is review. Now, the square root of x minus 2, this means we have to shift the original graph 2 units to the left or right. How we can shift it?
Right.
Right, exactly. Why? Because we have minus 2. The minus 2 means shift the square root of x 2 units to the right. So 0, 0, here 1 and 0, 2 and 0, be like this. This is the graph of f of x, here too. So here if I want to graph the function of x equal square root of x minus 2, so at the point 1, 2, now I have to graph the function of x like this. This is f of x. So this is the graph of f of x. Graph the function like this. This is the review. Here 2, 1, 0. Find the equation of inverse. By the way, this is one-to-one function. How I know? By the horizontal line test. Check the horizontal line test. The line intersect the curve at only one point. Okay, find the inverse. So step by step, I make the f of x equal y. Y equals square root of x minus 2. Now I have to solve it in terms of x. So how can I solve it in terms of x? What's the first step here? Any help? What I have to do first?
Where? Both sides.
Square both sides. So if I square both sides, I will cancel the radical here. So I get here y square equal this with 2, they cancel each other, so I get x minus 2. Now I have to move this 2 to this side. So to move this one, I have to add, right? I have to add 2, add 2. Now I get y square plus 2 equal x. Or x equal y square plus 2. So f inverse, instead of now interchange x by f inverse and y by x. So f inverse of x equal x square plus 2. This is my inverse function. But this function is not one-to-one. It will be one-to-one if I use if I use the range of this. So look here. I have to find the domain of the f inverse. The domain of the f inverse is the same as the range of the original function f. The domain of the f inverse is the same as the range of f. So what is the range for the function, this one? By using the graph, what's the range? What is the y values are used? Which y value are used here to graph this function? So as I see here, all the y values are used here from beginning of 0. So from this point up to this point, up, all these values are used. This is mean this is my range. So this is the range for a function f of x. So I can set the range of f of x, make space here. Range of f of x is the same as, is equal from 0 to infinity, is the same as the domain of n inverse of x. So the domain of f of x must be from 0 to infinity. So here the domain must be from 0 to infinity. So I know how to graph this function. The graph of this function is parabola like this. Then we have to shift it 2 units up. 1, 2. This is the graph of the function this. But the domain is from 0 to infinity. So from 0 to infinity I'm going to use. So this is mean I don't have to use this. So I have to remove this part of this side of the graph. To remove this side, I have to remove this side of the graph to make the function one-to-one. So this side is cancelled. I have to remove it. So the domain, because the domain is the same as the range of the function. So the new graph, sketch the graph of f inverse, is this graph. This one. This is f inverse of x. Make sense? Another way to find the inverse, the graph of the inverse, you have to draw x equal y. Here is x equal y. Y equal x. Then we reflect each point in this graph by this line. So here 2, 0. This point is 0 and 2. This point become here. This point come here. This point around here. So this is another way for graphing the function. This point around here. Any question? Any question? So it makes sense how to graph. You have 2 steps. The easiest one is by graphing the line y equal x, reflecting all the points around this line, easier than finding the domain and the range. Okay. So by this section, we finish all the chapter 2. Now we're going to over 3.1 quadratic function, chapter 3. Here I get a question, how we identify we need to use this or this. So here, the 0 is including in the range. The 0 is including, so including the range. Why? Because we don't have open circle. It's a closed circle at 2. You see? It is a closed circle at 2. So this is mean the value here, the value for the y is 0. So the 0 is including in the range. This point are including. And all this point also are including. For infinity, always exclude, always open circle, open parentheses. For infinity and minus infinity, always open parentheses. Okay. Now quadratic functions. C.1. So first of all, I have to define what is the meaning of a quadratic function. What is the quadratic function? Anyone hear about this definition in high school? What is the meaning of a quadratic functions? Okay, let me remind you. So the quadratic function is a function. Here is a function of the form f of x equal ax square plus bx plus c and a not equal 0. Okay, so this is, or I can say it's a polynomial of degree 2. This is a polynomial function of degree 2, or I can say it's a function of this form. So first of all, first step in this section, we have to know how to graph the quadratic function. So graphing quadratic function. So we're going to graph the quadratic function by using something is called the standard form. Okay, what is the standard form? So let me explain what is the standard form. So the quadratic function can be written any quadratic function f of x equal ax square plus bx plus c and a not equal 0. Here a must be not equal 0 can be written of the form f of x equal a of x minus h square plus k. This is the standard form. This is my standard form. So any quadratic function like this I can write it as this form. And by this form, I can graph any quadratic function. How can I graph any quadratic function by this form? Let me give you the steps. So the graph of any quadratic function is a parabola. Q1, find maximum and minimum coordinate. Yes, this is also I'm going to find the maximum and minimum by the standard form. So the standard form can help me to find the maximum and minimum values, can help me to graph the function, can help me to find the vertex of the quadratic function. So the graph of any quadratic function is a parabola. So this is a parabola with vertex. My vertex is h, comma k. This is the vertex here, h, comma k. This is the first step. So after I find the vertex, I can know how is the parabola. Mean parabola something like u. This is mean parabola. Parabola open upward or downward. It depends in the a. So I'm going to explain what is that. How is the parabola open? So first of all, I know the vertex for the parabola. The vertex, by using the standard form, I can find it by h, comma k. This my x coordinate. This is my y coordinate. So I have to know now if this a here is positive, so the parabola opens, mean parabola has a U shape, opens upward. And the function has maximum value. Is f of h equal k. So we're going to define to look into the a. If a is positive, greater than 0, so the parabola open upward, and also has a maximum value, not maximum, minimum value here, because it's open upward. So it has a minimum value. When open upward has a minimum value is f of h equal k. If a here now, this a is negative, then the parabola opens downward. And the same things, the function has a maximum value. And the function has a maximum value. Why maximum value? Because it's open downward. So it has maximum value. And the value is f of h equal k. So here minimum, here maximum. So the important things after we find the standard form, we have to check a. If a is positive, this is mean that it's open upward. If a is negative, is open downward. If it's open upward, this means the function has minimum value. and the value is f of h equal k. And the same things, if the parabola open downward, if a is negative, so this is mean the parabola open downward, I mean like open downward, something like this. This is the parabola open downward, like u, but open down. Here, open upward, like u, open up, like this. Has a maximum value is f of h equal k. Let me give you example, explain all these things. But before I give you example, let me graph two things to explain what is the mean of a is open upward and a open downward. So if f of x here, for example, my function f of x equal a x minus h square plus k, and this a is positive, this means the function open upward like that. This is the parabola. Okay, different way like this, or bigger. This is my parabola, and this here is called the vertex, and the vertex here, this is vertex. The vertex is h and k. This h, my x coordinate, and k, my y coordinate. Now, if f of x equal a times x minus h square plus k, and a here is negative, this means the function open downward, something like that. And this value here is the minimum value. Here is a vertex, and this is my maximum value. The vertex has x coordinate is h, and y coordinate is k, and its parabola open downward. Here parabola open upward. So let me now give you any question before I go to the example.
Is it possible to be like in like the negative axis?
Yes.
Oh, okay.
It's like it's maybe something like that. Maybe like that, whatever.
Okay, cool. Sorry.
But the important things, it's open downward like this. This is the important things.
That's if it's negative, right? If it's negative, it's upside down.
Yeah, because a is negative. Yes.
Okay.
Here
Cool.
because a is positive.
Awesome.
Yes. Now let's go to the example. So I'm going to, yeah, okay. So put my example here. So consider, let me move it a little bit. Here, example. Consider a quadratic function f of x equal, I'm going to choose a simple example. F of x equal like 5x squared minus 30x plus 49. So first of all, this is the quadratic function. Why? Because it has a form ax squared plus bx plus c. My a is 5, my b is minus 30, my c is 49. So I have like some steps, like 5 questions here. The first step is express f in standard form. This means I have to express the function as in this form. Find the vertex and the y-intercept. Sketch the graph of f. Find the domain and the range. Find the minimum or maximum value. So I'm going to do the first step, express f in standard form. I'm going to do the first one step by step. So A, express f in standard form. This means I have to write down the function as f of x equal a times x minus h squared plus k. So first of all, I take this function. So my function is 5x f of x equal 5x squared minus 30x plus 49. So the first things here, I have to take the first two terms. This is the first step. Take two terms. Now I try to factor this one, the first two terms, such that the coefficient for x squared equal 1 only. So the factor for this one is f of x here equal the factor for the first two terms only, such that I make the coefficient of x squared is 1. So I take the 5 because the 5 is the greatest common factor between the first two terms. So 5, open parentheses, I get x squared minus 6x because I factor, I take the 5 outside, plus 49. This is the first step. Now, I need to do something here, is completing the square. I have to complete the square for this parentheses. Divide by 2. Why I have to divide by 2? Divide everything by 2. Why I have to divide by 2? I don't need it. We don't need to divide by 2. So I need to make the coefficient for x squared is 1. So to make the coefficient of x squared is 1, I have to factor the first terms by 5. So the 5 is the greatest common factor between this term and this term. So this is like chapter 1. So after I factor it by 5, here remaining x squared minus 6x plus 49. Now I have to do something here, is completing the square. So to complete the square, I have to add, to complete the square, I have to add b over 2 square. So in general, I have to add b over 2 square and in the same time here, I have to subtract, 5 times b over 2 square. This is my step, I have to do it here. I have to add inside the parentheses b over 2 square. Outside the parentheses, I have to subtract 5 times this 5, I mean, times b over 2 square. So let's do it. So I have to add now, what is b? It's minus 6. Over 2, it's minus 3. Square is 9. So I have to add 9. I have to inside the parentheses the 9. And I have to subtract outside the parentheses 5 times 9. So now I get f of x equal 5, open parentheses, x squared minus 6x plus 9 plus 49 here minus 5 times 9, it is 45. So this things here is the same as, let's come here, and the 9 here, I add it, it is here. Make sense? Now, I have to simplify this function. So now I get f of x equal 5 outside, open parentheses, x squared minus 6x plus 9 plus 49 minus 45. They give me what? Plus 4. Now I have to factor this parentheses here. What is the factor? For x squared minus 6x plus 9. What is the factor inside this parentheses?
-3.
What's the
X-
factor? Two parentheses. What is the first
X
parenthesis?
minus 3, x minus
And x minus 3. Or I can say what? Mobin. What does that equal? X minus 3 what?
square.
Square. So now I find it like 5 open parentheses x minus 3 square plus 4. And this is my standard form, like this. So now this is my standard form. This is the standard form I'm looking for. So by the standard form, I can graph the function. I can do whatever I want. I can find the vertex. I can find the minimum and maximum value. I can find all the steps B and C and D. Here I get something wrong. Here is C. This is D. And this is F. So this is my standard form. Again, you take the terms, you factor it such that you make the coefficient for x squared 1. Then you have to add b over 2 square. You have to subtract outside 5 times b over 2 square. Now I get another equation, another function. I mean like the same function but in different form. Now we have to factor to complete the square for the parentheses. I get the standard form. Second step, find the vertex. What is the vertex from this one? Going back, the graph is a quadratic function is a parabola with a vertex h and k. So my vertex from the standard form is h, this h, comma k, this k. So what is the vertex now? Is h and k. So number 2, or I mean like B. So first of all, the function, so f of x, the standard form is 5 times x minus 3 squared plus 4. So the vertex is open parentheses, comma, h is a 3, not minus 3 is 3, the positive, and 4. And the y-intercept this is like by setting x equals 0. So when you set x equals 0 here, or I'm going to use this function of x equal this. So by set x equals 0, so my function f of x equal 5x squared minus 30x plus 49. I have to plug the 0 inside this function, get f of 0 equals 0 minus 0, because 5 times 0 is 0, minus 0 plus 49. So my y-intercept is f is 49. Is 49. The vertex, the y-intercept. Any question? Makes sense? Clear? How I find the vertex? From the standard form. How do I find the y-intercept? By set x equals 0 inside the original function. I get 49. Now number C. Sketch a graph of f. So how to graph the function? So to graph the function, I need the vertex, the y-intercept, and a. If a is positive, I need a. I need a. A is equal 5. Is positive. So this means the parabola open upward, like this. I need a vertex. 3, 4. I need the y-intercept. Is 49. So at the point 3 and 4, this is my 3 and 4. 1, 2, 3. 1, 2, 3, 4. So it will be like around like here. And it's like parabola open upward, and the y-intercept is 49. So the graph will be something like this. So I mean, like the y-intercept is 49, it's up. I cannot show it here, but the graph will be something like this. 1, 2, 3, 4. The curve here intersect the y-axis at the point 49. If you want to show it, go down this one, it's down, and here. Graph it again. So it'll be like around something like this. Here's vertex 3 and 4. This is 3. This is 4. This point is 49 and open upward because 5 is greater than 0. So this is C. Now D. Find the domain and the range from the graph. So from the graph, I can find the domain. The x value are using in the graph, it's the domain. So this is my domain. All this value are my domain. So this is the domain for the function. All the values are used. What is the range? The range is starting from this point. From this point to infinity. Christopher. Yeah, the domain, it's from minus infinity to infinity. What's the range? From this point, from the vertex to infinity. But the domain, all this point. So here, this is C, here D, domain is R, real numbers. Or you can write it as open parentheses from minus infinity to infinity. The range from close interval from 4 to infinity. Yeah, Christopher, how would you write it in the web sign? You can write it as R, or you can write it as open parentheses here, sorry. From minus infinity to infinity. And the range from 4 to infinity. The 4 is including. Why? Because this point are including in the range. Makes sense? Now find the minimum or maximum value. So again, to find the minimum or maximum value by using this property. A is positive in my question. So this is meaning the function has minimum value. What is the minimum value? Is f of h equal k. So in my question here, A is 5, is positive. So the last step here, question F, A is equal 5, is positive. So the function has minimum value is f of h equal k. My h here in the question is 3 and k is 4. F3 equal 4. This is the last question here, last F, find the minimum or maximum. The function has a minimum value, not maximum. How I know? Because a is greater than 0. Any questions so far? Okay, we're going to stop up to here today. Anyone has a question from WebAssign?
Yeah, Professor, can you show us the composition functions, the domain?
Yes, I'm going to show it. Okay. So the lecture for today will be until here. I'm going to show you how to find the domain and the range for, the domain for the composition function. Okay, let's go to the website. Example. Consider the following function f of x
Yeah,
equal 6x minus 5, and the other function is g of x equal x over 2 or x over 3. So the function find f circle g of x. So let's do it step by step. So first step here, ask what is f circle g of x. So to find these things, like I said before, this equal f of g of x. So you plug the g of x inside the function. So f of x over 3, you plug this one inside the function f. So I get now 6 instead of x over 3 minus 5. I can simplify it by dividing 3 with the 6. So I get 2x minus 5. This is the first step. Second one, find the domain of the function. Okay. Number 2, find the domain of f circle g of x. So to find the domain, you ask yourself, what element can I plug it inside this function such that will be defined? They will not give me any problem. Can I plug the 0 inside this function? So my function f circle g of x equal 2x minus 5. Can I plug 0 inside this one? 2 times 0 is 0, minus 5 is minus 5, so it's fine. Yes, I can plug 0. Can I plug positive numbers like 1, 2, 3, 4, 5 to infinity? Let me pick number 2, for example, is the positive numbers. 2 times 2 is 4, minus 5, you give me minus 1, so it's fine. So I can plug here any positive numbers, no problem, no issues. Can I plug negatives? Yes, I can plug. For example, minus 2. 2 times minus 2, they give me minus 4. Minus 5. 2 times minus 2, they give me minus 4. And minus 4 minus 5 is minus 9. So it's fine. So this is me, and the domain is all real numbers. So the domain is R. Or I can write it in a different way, from minus infinity to infinity. This is the domain. What element can I plug inside the function and keep me defined? No issues. The other question here, number 3, it makes sense here? Is it clear how to find the domain?
So we just plug in like any numbers and
Yeah, you have to plug the numbers and check like zeros and positives and negatives.
so we could just plug in any random number.
Yes, I tell you something. If the function is linear, this is a linear function. Always the domain is R.
Oh, so it would be negative infinity to infinity if it's a linear
Always.
function.
Always for linear function, always real numbers, always.
Oh, okay.
If the function here is a quadratic function, what does I mean of quadratic function? Like this, parabola, something like that, always the domain is R. Something like that, a square plus bx plus c.
So for quadratics and linear, it's always R.
Always, always. I think you another things for the domain for any polynomial. This is the polynomial function, always R. X and minus 1 plus plus a1 plus 0. This is polynomial. Like for example, b of x equal x cube, or b of x equal x to the 7 plus x to the 6 plus or minus 1. Something like that. Always the domain is real numbers. Okay?
Oh, okay.
Or you can plug the numbers for this one. But something like that, f of x equal 1 over x. So this function, for example, I cannot plug the 0. Why? Because the 0 is in the denominator and 1 over 0 is undefined. So this is mean the domain for this function is all the numbers except the 0. How can I write it? Like this, from minus 0 infinity to the 0, open parentheses, union from 0 to infinity. Or I can write it as x such that x not equal 0. But if you want to write it in Weber sign, you have to write it like this way.
How about if it was the opposite, like x over 1?
X over 1.
Yeah.
The function here is polynomial, like this. So the
Oh,
domain
so that
is
would be all real numbers?
all real numbers. I can plug positive, negative, zeros, no problem, no issues.
Oh, okay.
What about something like 1 over x minus 1? What is the domain? The domain is everything but except the zeros for the denominator. What is the zeros? What element, if I plug it here, they give me 0?
1?
1. So everything except 1 is the domain. Or I can set from minus infinity to the 1, union from 1 to infinity. This is the domain. Is it clear?
Yeah, how about if it was like the opposite, but it was like 2x
minus-
minus 1 over 1?
Like f of x equal 2x plus 1 over 1.
Yeah, something like that, or 2x minus 1, either one.
This is polynomial function.
Oh, so it'll be R?
Equal to x plus 1. This is polynomial, linear.
Oh, okay.
So the domain is real numbers. I can
So if it was 2x minus 1 over 1, it would be the same thing?
what is the
All real numbers?
which one?
Oh, 2x minus 1 over 1. It would be the same?
Same things. Because this is equal to x minus 1, because anything over 1 is the same like the numerator. So this is polynomial. The domain is the real numbers. And this
Oh,
is
okay.
linear function. Okay?
Oh, okay.
So, but in general, if you find something in the denominator, like first of all, when you check in the denominator, like for example, the function d of x equal to x plus 4 over x minus 1. The problem, no problem in the numerator. I can plug any numbers here, no issues. But the problem here I have to make it not equal 0, because if I plug numbers here and give me 0, this is mean the function here undefined, and the issue here is 1. I can't plug 1.
Oh, so
All the numbers except the 1 again. I get another question. What about 6x? 6x minus 2 over 3 is real numbers, all real numbers. Okay?
What would be the domain for the top one that you did?
This one,
The third one, d of x.
this is from minus infinity to 1, union 1 to infinity.
Okay, so it depends on the number in the denominator, like the
Denominator.
1.
Yes.
So if it was a 3, would it be from negative infinity to 3 and from 3 to infinity?
Which one?
No, if you were to change the 1 and put a 3, it would be
3,
the same.
ye-
It would just be
yes.
a 3, right?
Yes.
Oh, okay.
Okay. Any questions so far?
Yeah, sorry. Are you able to go over the how to find like the net change?
Which one?
Like the net. Which one is it? 2.4.
2.4. Okay.
Yeah, like net change and the average rate of change, because some of them are confusing with the ones with the letters, the variables.
So which question? Like, for example, I give you another example here. Yeah. So the example, the function f of x equal 3 minus z square minus 4z square. So the question determine the net change between the given value of the variable. So find the net change between z equal minus 2 and z equal 0. So the net change equal f of 0 minus f of minus 2. So you plug the 0 inside the function, I get 3 minus 0 is 3, minus the minus 2 inside the function, I get 3 minus 4 times 4 is 16. I get 3 minus 16 minus 3 is minus 13, so plus 13. Here I get 16. Second one, the average rate of change. Rate of change equal the net change so the net change here equal over net change over 0 minus 2. 0 minus 2. So the net change is 16 over 0 minus 2 is 2. I get 8. So for the net change, you start from this point minus this point. For the average rate of change, you put the net change over 0 minus this point. Is it clear?
Yeah. How would you do one with
Yeah.
well, some of the web assigned ones had like a plus h, and one of them equals a.
Which one? Which question?
It's for the same one, but it's like t equals a and t equals a plus h.
Okay. So I'm going to erase these things, okay?
Mhm.
So this is a and z equal a minus a, right? Minus 1. So you plug.
Oh no, it usually has like a plus h or a minus h.
Plus
Like
h
has
like
two
this,
variables. Yeah.
like this.
Yeah.
Okay. So the net change equal f of a plus h minus f of a. You plug this point inside this function, 3 minus 4 for a plus h square minus 3 minus 4 of a square. You simplify these things, 3 minus, like for example 4 here a square plus 2ah plus h square minus 3 4a square. And you have to simplify everything. This is the main idea, how to plug it. This makes sense here? Is it clear how to do it? You plug the first one inside a function, second one inside this one. And you have to
Yes.
simplify and you find the answer. For the second one, average rate of change, you get the answer here, you put it here, over a plus h over this one minus this one. A plus h minus h minus a. So you give me these things over a plus h minus a, they give me h. And this is the answer. Makes sense?
Okay. So whatever you get for the net change, then you just put it
Put
over the
here.
two.
Yes.
Oh, okay.
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 Any other questions?